Welcome to Semantic Web Technologies. This is lecture number 6, Applications in the Web of Data. Today we want to talk about linked data engineering. And we have already heard about linked data and the linked data cloud in the first lectures of this course. So, it's about data on the web. How do I get data from the web today? So, of course, data can be found on the web, and it's available on some websites. So you have tables there, and there is data inside these tables. But where do they come from? So usually, you have a web server, and the web server delivers, of course, the HTML page that you see in your browser. And there, the delivery, of course, works with HTTP protocol. And the database is usually connected to the web server, sometimes via, for example, JDBC as an interface. And then the data comes from the database to the web server and is transferred to the user via HTTP. So, how to access this data? Usually, there is a number of different and proprietary so-called web application programming interfaces. There are data exchange formats. And what you can do with that, of course, you can combine this data in so-called mashup applications. But what you have to do is you have to use several different and proprietary APIs. And the problem is, as soon as here the exchange format or the interface definition changes somehow, if the API changes, then of course you have to rewrite your entire application. And this might occur rather often. And the more different APIs you are using, the more complex this task will be. So the problem today is that the data somehow is locked up in small kind of data islands. And usually other applications cannot use this data. So for example, Google not necessarily is able really to use, let's say, the index or the catalog of Amazon and vice versa. So of course they have their own database, but they of course do not share this database with the public. And when they do it in a rather controlled way. So the data cannot simply be combined and then published anew, let's say, with some new and enriched content. So this is a problem. But we already know the solution to this problem. We know semantic technologies, and we can use semantic technologies to publish also structured data in the web, simply by transferring or translating this data into RDF and OWL ontologies, and then, of course, to publish it as RDFF-based data. And then we can draw connections from one data source to data from another data source. And what we come up with is so-called linked data. And to publish linked data, of course, there are rules. There are best practices to publish linked data. And now we want to talk about these best practices. So it's called the linked data principles. How should I publish linked data? So this is pretty simple. You see, we have 4 points. First thing, use URIs for names and things. Then use HTTP URIs so people can look up those names, so they are dereferenceable. Then, of course, when someone looks up this URI, then I should provide useful information. And I do this by using the W3C standards. It means by using RDF and SPARQL. And the most important thing is I should include links, of course, to other URIs so that one can discover more things. Let's go into these principles in detail. So the first thing is quite clear. Of course, we use URIs as names for things. So we identify things on the web with names. We have already talked about this in the very first lecture of this course. So, for example, I can talk about the content of a blog when I use here the address, for example, of our Jovisto blog with a history of science. I can talk about Albert Einstein when I use the identifier in the DBpedia of the resource Albert Einstein, or I can talk about the Beatles when I use the identifier of the Beatles at the Music Brains database, for example. So these are URIs that identify things, information resources on the web about things of the real world. We have already talked about this issue. And you should use, of course, URIs. Otherwise, it's not possible to publish linked data. Then, of course, we must have the possibility to look up these URIs. It means it should be HTTP URIs, and HTTP URIs means that when I look up the information that is behind this URI, either I will get really information that is readable for humans or information that is readable for machines. And this can be achieved via so-called HTTP content negotiation. So for example, with this relaying 303 HTTP, with, possibly you know the HTTP response code 303C other. This is a redirect response code. This is used in content negotiation, for example, to differentiate between the HTML content for the humans or the RDF content for the machines. And this, of course, is dependent of the header of the accept header of the HTTP message that is processed. On the other hand, we have already all seen how I can distinguish between an information resource and really an object that is really identified within this information resource. You can use this with these so-called hash URIs. So for example, if this is me or information about me, then hash me, this really designates me as a person within this information resource. Okay, let's go back to the content negotiation. Dependent on the HTTP accept header, you can write there application/RDF and XML. Then you will get back from the original URI the RDF data. And you can also write in the accept header text/HTML, and then you will get back the HTML page. So what happens here at the web server is the following. You have here the GET request via HTTP. You have here the accept header format application/RDF XML. This goes to the web server. The web server reads the accept header and then decides, okay, here RDF should be the response, and therefore this RDF data is at another URI. So therefore, it sends the response code 303, see other, and sends also the location. It means the new URI of this data. And this, of course, comes to the client, and the client then can finally access the right URI that has been communicated from the server, and again then reaches the right endpoint on the server to access the RDF data there. So in the same way, it's also provided for HTML. And you have already seen this also in the homework of the course for the first lecture. There you had the question for the URI of resources in DBpedia. And of course, you have noticed that there is a difference between resource and page within the DBpedia. So for example, here we have the resource Ernest Hemingway, which really denotes the resource itself. And now it depends on the header here, on the accept header, whether you will get the HTML page back or another URI with the RDF data. Okay, URIs are dereferenceable. And the information that is stored behind the URI should be, of course, useful. And by doing this in the semantic web, you should use W3C standards. This means you should use RDF as a universal data model for publishing structured data on the net. And of course, you should make all URIs that are used in the RDF graph, they should be dereferenceable. And also, best practice says that you should avoid certain constructs in RDF that might cause problems in linked data. So for example, the RDF reification is always difficult, especially if you use OWL and you want to be or stay decidable or computable, then you do not have to use reification because their classes and instances or also relations, properties, and instances can be mixed up, and you can also end up in endless recursions, for example. Another thing you shouldn't use, or which they say you should not use, is RDF collections and containers, and also so-called unnamed blank nodes. Unnamed blank nodes you should not use for linked data simply because they are not accessible from outside. So, okay. Number 4, of course, the most important principle in the linked data principle is the linking principle. It means you should include links to other URIs. So this is really important. So link RDF references among data between different data sources. So to find then information that is related somehow via content. So you distinguish there between so-called relationship links, links to other or external linked data, resources related with the original entity, or identity links. So these are also links to external entities referring to the same object or the same concept, but they are defined in two different ontologies, in two different vocabularies, for example. And there are also called vocabulary links, and these are links that link an object to its definition of the original entity. So these are the four linked data principles. And when you apply them, you will end up in a web of data. So the application of the linked data principle leads to a web of data. And now we want to take a closer look to the linked open data cloud that we already have seen. So the linked open data cloud developed out in 2007 and started, you see here, with a small number of data sets. DBpedia as a reference for the Wikipedia in the center. You had also friend of a friend. It's a large network among people. You had Music Brains. You had the US Census data. You had geographical information within GeoNames. You had the CIA World Factbook. You had lots of literature, for example, in the project Gutenberg. And you had here also bibliography data from computer science in the DBLP. So this only as an example. This was the starting point in 2007. But this soon developed. So already in November, you see there new data sets came or popped up. OpenPsych, for example, as a much older ontology there appeared and was translated into linked data, and also the data from the conferences, ISWC, ASWC, for example, they popped up. Then 1 year later, in September 2008, you see much more also from the media domain here. The BBC programs or the BBC play count data appeared here, and also social media data started to be part of the linked data cloud. Then in July, 1 year later, 2009, even more, and now I do not explain each single data set that came up, 2010, and now 2011, because for 2012 the count has not finished now. So the last numbers we can refer to are from September 2011. There we had about 300 data sets with 31 billion RDF triples or RDF facts that were connected by about 500 million links. And the growth continued. To make your data available on the linked open data cloud, Tim Berners-Lee, you remember the inventor of the World Wide Web and also the semantic web, he issued or published so-called 5-star criteria for linked open data. So when you publish linked open data, it means you publish your linked data as open data, so it's public, and it's published under the Creative Commons license you see here. And then you can add up to 5 stars, depending on in which way you make your data available. So let's have a look at the stars. The first one, pretty simple. I make something available on the net with an open license. Then I have 1 star. So this has nothing to do with linked open data, of course. It's open data in that sense. If this open data is not only text, but is machine-readable, structured data, so for example, it's an Excel spreadsheet instead of an image scan of a table, then it gets already 2 stars. But of course, Excel, as in our example, is a proprietary format. If you publish it in a non-proprietary format, for example, a simply CSV format instead of Excel, then you have 3 stars. And moreover, if you are using the W3C standards, it means RDF or Sparkle, then you will get 4 stars. And the most important thing, of course, when you link your dataset to other datasets within the linked data cloud, then you will get the final 5th star. So you can look it up here at http:5stardata.info. There you can see all what is relevant here for the publication of linked open data according to these standards. So what can I do with this linked data or linked open data? Of course, like with other data on the web, I can build mashups. mashup applications, but now they are semantic mashups. And this means these are applications that use linked RDF data from various sources. But in difference to traditional mashups or to ordinary mashups, we do not have to use different web APIs. Linked data offers several benefits. We have, first of all, a flexible and standardized data format, RDF. We have a rather standardized access mechanism, simply HTTP. And we have the possibility to put links among different data sources. So these RDF links, they enable navigation. They are supported by search engines, so the crawler will follow them. And then, of course, it enables also the application of expressive search facilities over the crawled data and even beyond. And how to program these mashups and what is important there, we will cover in the next part of the lecture.